Alright, solving an equation is a big deal in algebra, and so we're going to learn how to solve equations using addition or subtraction today, or one-step equations as they're often called. And I always like to start thinking about the idea of solving equations as keeping a balance. And so the balance I want you to think of as the center point being the equal sign of any equation. And so if you have, let's say, a box here, and we don't know what's in there, plus two triangles. And we're going to call our box our unknown thing because we don't know what that is. It's really starting to formulate an equation. You have some unknown weight of that box plus two of your triangles. And that equals, because this thing is balanced, it equals something on the other side. So let's say we had 4 triangles over here, okay? So some unknown quantity plus the 2 triangles on the left side equals 4 of the triangles on the right side. The idea that's really important in solving equations is that we can solve this for x. We can do it with mental math, but that's not where we're at here. Is I can take away 2 of these triangles, okay? And if I take them away, you know what's going to happen to your balance. Your balance is going to rise, right? And suddenly you're not equal anymore. And so I can't just take away 2 items from the left side without taking away 2 items from the right side, because I won't be balanced anymore. And we need to stay balanced because that is the point of a balance. So I would take 2 away from the right side as well. And then my balance would come back to level. All right? That really is so fundamental to math. And what you've done there is demonstrate the idea of equivalent equations. And so I could take away 2 triangles from this side and 2 triangles from that side and end up with a situation where I had the one unknown x there, and that left me with 2 triangles on the other side. These 2 equations are equivalent. They are balanced. And so equivalent equations may look simplified, but they're still the same. And they'll remain that way as long as whatever you take away from one side of your balance, you also take away from the other, or add if that's the case. Simplified, but equal. So when you're solving equations using addition, subtraction, multiplication, division, every time you write a new equation, it still must be equal to the one before it, and it will be as long as you follow the rules. I want to dig into what solving an equation means just real quickly, because we've talked about simplifying an equation, and that is just performing operations to make it a smaller version of itself. We've talked about evaluating equations, and that's just substituting a number in for a letter. Well, solving equations means you are going to actually find out the value of something unknown. And here I've written it out again. So you're going to operate on an equation like you're the doctor, and you will add things to something or subtract things, kind of like performing surgery. You're going to operate on an equation, and this is something we didn't talk about with simplifying or evaluating, because now we're talking about equations, and so there'll be equal signs, and you can solve for something that we didn't know, the unknown value. And so usually it means we're finding out what x is or what y is by ripping things away from it. So here are 2 overarching ideas that we always need to use when solving equations so that we're doing it right. It's always important in math to know where you're going, like what is the point of what you're doing. And when you're solving equations, your goal is to isolate that variable. That just means get it alone on one side of an equal sign. So your goal, keep it in mind, is to get the variable alone. And you need to follow these 2 rules. The first rule is the golden rule, which I talked about with the balance. And that is that whatever you do to one side of an equation, you must do to the other side, or you don't have equivalent equations anymore, and your balance is unbalanced. So the golden rule is whatever you do to one side of the equation, you must do to the other side. And then you need to memorize the idea of the inverse operation. That is the actual thing you, the mathematician, are doing to the equation in order to get x by itself. I, again, like to think of you as the surgeon because you're inversing the operations. So you use inverse operations to solve. And let's talk about what those are. Inverse operations are operations that undo another one. All right? So they're opposite operations. A lot of people like to think of them like that too, which is totally right on. So if I asked you what the opposite of addition was, like what undoes something being added, hopefully you would say subtraction. And it works in both directions. The opposite of subtraction is addition. And the opposite of multiplication is division. If you want to undo something being multiplied, you're going to divide it. In division, the opposite is multiplication. I apologize for my handwriting. Multiplication. And my spelling. Although I'm right here. So these are your major things to remember. They are your inverse operations. And the idea of undoing stuff is huge in math. So get used to hearing about undoing things. So let's put everything we've learned so far in this video together. We're going to solve equations by using inverse operations. So let's look at letter A. I have the number 4 being added to some unknown value, and that equals 10. I understand that you can do this with mental math, but this is not the point. This is mathematics here, so we're going to use processes and procedures because this will get definitely more complicated. This 4 is being added to my x, and so I need to subtract 4 from both sides to undo it. And I need you to write that out. So I'm going to undo the addition of 4 by subtracting 4 from both sides. That's the golden rule there. And I will produce a balanced equation. And so then you just simplify each side. Because I took away 4, these go away, leaving me just an x. And when I do 10 minus 4, that's just simplified to 6. So you've reached your goal. You have solved for x. You know that x was 6. Letter B. You have x plus 3 on the right side, and that equals 7. And so we will subtract 3 from both sides to undo that addition. You're always working on the side with your variable. You don't really care about the other side. Keep your eye on the goal, which is to find out what that x is. So I subtracted 3, and so I'm going to simplify my right side to get an x, and simplify my left side. 7 minus 3 is just 4. So you've reached your goal. Again, you have isolated your variable. You see that x was 4. Well, now we have multiplication going on between the 2 and the x. And the only way to undo multiplication is to divide. So I'm going to divide by the 2. Again, you're looking at the side with the x. So I will use the division bar to show my division. I don't want you to use that other division symbol. And then I'm going to divide by 2. And this is undoing that multiplication because we all know 2 divided by 2, well, that's just 1, and so it's gone. So simplify your left side and simplify your right side, and you have that x equals 4. Let's do one with division. If I have x divided by 4, and I know that that equals, let's say, 5, I need to be able to solve it for x using inverse operations and the rules of solving problems. So I need to undo this division. Say to yourself, what undoes division? Hopefully you're going to say multiplication. And I want you to write it upstairs because I'm multiplying this whole expression by a 4. Okay, don't write it downstairs and use the dot instead of the x. And then your 4's are undoing each other because 4 divided by 4 is just 1. So then you're left with x equals, and just simplify the right side and you have 20. I should say too that You should never be wrong on any of these that you're solving, because you can take your final answers and substitute them back into the original problem, and you should have a true statement. The left side should equal the right side. All right, let's have you guys do these guided practice. You have to show your work. I'm not interested in x equals something showing up. I want to see how you got to your answer. Pause the video. And here's what your final answers should look like. Again, if you showed no work on this page, you are not learning what you're supposed to, and that is starting you on the process of simplifying equations, because again, they're going to get much more complicated. Baby steps, right? So all the steps in red should be shown. Just another little word. Sometimes kids like to switch around your y and your numbers, and you can do that, but I kind of just advise that you leave it on the side where it starts at and just operate on that.